All right, guys, today we're going to be doing some more u-substitution. Let's start off by making sure we know our u-substitution from our previous class. What is the antiderivative, the integral of this function here? And hopefully we can recognize that the inside function, which will be u, is 3x squared minus 1. That's inside of the square root function. And the good news is that we have its derivative, du, the derivative of this, the derivative of 3x squared is 6x, and that's right here. So the chain rule says when you do the derivative, you always end up multiplying by the derivative of the inside function, and we see that right here. So we can divide by that derivative of the inside function, and if the x's cancel out and we don't have any x's left over, we will be able to do this integral. So this is the integral of the square root of u. I've substituted 3x squared minus 1 with u, du. We've switched it to u's. And let's see, to do this, we need to do the power rule. This is u to the 1/2 power that we're doing the integral of. So we're going to raise the power by 1. 1/2 plus 1, written as 2 halves, is 3 halves, so u to the 3 halves power. And we have to divide by 3 halves, so 2/3 u to the 3 halves power plus c. At the very end, we're going to go back and substitute what u was. U was 3x squared minus 1, so it's going to be 2/3, and we should rewrite it back as a square root. So this is a root, this is the square root cubed, and u is 3x squared minus 1. So here is the antiderivative. And again, let's just make sure we understand why this ends up working, right? When we do the derivative, we'll lower the power by 1, and we'll end up back with this power. We'll multiply by the 3 halves, that'll get rid of the 2/3. And when we do times the derivative of the inside, that's where that 6x will come from. This is chain rule in reverse. Okay, what is the inside function here? And if you said it was 3x, the problem is that, like, well, okay, let's say it's 3x, well, then what? Like, if u is 3x, then du would be 3, and there's a whole bunch of, like, other stuff going on. So you'd get, like, sine squared of u du, or, sorry, times cosine of u, and now there's still, like, multiple functions that we don't know how to do the integral of. Instead, if we pick sine of 3x, so u is, the inside function is, u is sine of 3x, then the derivative of sine of 3x would be cosine of 3x, the derivative of sine of something is cosine of something, times the derivative of the inside, which is 3. And so, so here we've got u squared, and we can divide by the derivative of that inside function. So sine of 3x is getting squared, and the derivative of sine of 3x is cosine of 3x times 3. When we divide by cosine of 3x times 3, the cosines will cancel out, and we're still dividing by 3, so this is 1/3 u squared. So, you know, was it exactly the derivative like it was over here? No, but it's okay if there's a constant multiplier, because the constant multiplier rule for derivatives and antiderivatives involve just like leaving the constant multiplier alone. So let's do this integral. We're going to raise the power by 1. We're going to divide by the power. 1/3 divided by 3 is 1/9. So this is 1/9 times sine of 3x cubed. And we usually put the cubed here, sine cubed of 3x plus c. Hopefully we feel okay about that. Again, I want to very quickly show you that you don't have to use u. You can be like, aha, I see that sine of 3x is the inside function, so I'm just going to divide by the derivative of sine of 3x, which is cosine of 3x times 3. The derivative of sine of 3x is cosine of 3x times 3. That'll cancel out the cosines of x. And so we have 1/3, and then we're just doing something squared. So it's going to be that thing cubed, and we have to divide by 3 to cancel out the cubed. So we don't have to use u's, but we could. How about this one? Well, hopefully we can see that the u absolutely has to be 2x squared minus 1. That's the function that's inside of another function. And the derivative is 4x Now, we don't have 4x there, but that's okay. The x's will cancel out, and that's the important thing. If the x's didn't cancel out, then we wouldn't be able to do it. So this is 3/4. I'm going to call this u to the 1/2 power. So I just rewrote. So this is u, and then square root is to the 1/2 power. So we're going to raise the power by 1, and multiply by the reciprocal, divide by 3/2. So what do we have? 3/4 times 2/3, 6/12. Divide by 6, divide by 6, that's 1/2. So it's 1/2 square root of 2x squared minus 1 plus c. Oh, cubed to the 3/2 power. So hopefully we're feeling pretty good after, you know, this is always a little slow to start, but after you got done with your homework last night and got enough practice in, it should be starting to like come together pretty well. It usually starts a little slow, but once you've gotten practice, everybody gets very good at it. So let's look at some AP stuff. First, let's look at how it would look in a multiple choice. I think you guys can just do this. Which of these is the antiderivative? And I hope we noticed that this is cosine of something. So it's like the u is obviously going to be x cubed. So du is 3x squared. And so this is going to be the integral of, we're going to divide by 3x squared. And there's a 1/3 left over. 1/3 cosine of u. And so when we do the integral, the antiderivative of cosine, so it's the 1/3, the constant multiplier is still going to just stay there. And the antiderivative of cosine is sine. The derivative of sine is cosine, so we don't need like a negative sign there. And so 1/3 sine of x cubed plus c. Now, you could do this by just doing the derivative of each of these and seeing which gives you this up above, right? So in this case, the answer was sine x cubed plus c. You could have just done, wait, hold on. Oh, yeah, okay, for a second I thought it might be this one. This would be a product rule if you tried to do the derivative of it. Okay, so here's something new. Today what we're gonna be doing is we're gonna be looking at applications and definite integrals. So here we've got the integral from 0 to 2 of square root of 2x plus 1. And I'm gonna let you, I won't count this for points on this because you're gonna get it wrong, it's okay. Which one of these is the correct integral using the u-substitution? See, this is a chain rule one. It's a function inside of a function. So which of these is the correct integral based on this? Well, hopefully you said u is 2x plus 1, and the derivative then would be just 2. It's just a constant, so we can divide by that constant. So this is the integral of, we're going to divide by 2. This is 1/2 u to the 1/2 power, or square root of u. I guess it's just how they left it. So I suspect that a lot of you picked B. Obviously, I haven't seen you answer it yet, but I bet a lot of you picked B. And this is like the best answer you could have picked. But it turns out that the limits will also change. So because u is 2x plus 1, this is saying x goes from 0 to 2. Well, if x goes from 0 to 2, and now this is in terms of u's, then u isn't going to go from 0 to 2. U is based on x. So the lowest value of x is x equals 0. And so what we're going to do is we're going to put in x equals 0 into here. And so the lowest value of u goes from, when x is 0, 2 times 0 is 0, plus 1 is 1. U goes from 1 to, okay, the biggest x value will be 2. And so when x is 2, 2 times 2 is 4, plus 1 is 5. U will go from 1 to 5. So this integral initially was saying, look, we're going to find this square root where x goes between 0 and 2. And now we're saying, okay, well, we're switching it to u's. The limits will also change to match what u is equal to. So you plug in the lowest x value, you plug in the highest x value, and that tells you what the lowest and the highest u values are. So in this case, the answer was actually C, which, you know, you had no way of really knowing ahead of time, but now you do know it. So there's actually 2 ways of doing this. I want you guys to try to rewrite this using u-substitution as we did just a minute ago. And hopefully what you did was you said, well, u is going to be the inside function, x squared plus 1. And so du is 2x. So we're going to divide by 2x. That's lucky, it's just right there. So this is the integral of u cubed du. And x went from 0 to 1. So u, when x is 0, u will be, when x is 0, we plug in 0 here. 0 squared plus 1 is 1. When x equals 1, u will be, we always find it based on what x is. This is a formula for u based on what x is. When x is 1, 1 squared plus 1 will be 2. So u will go from 0 to 2. So we can do it this way. We can raise the power. This is u to the 4th power from 0 to 2, and you can just like plug it in from here. This is 2 to the 4th, so 1/4 of 2 to the 4th power minus 1/4 of, we're going to plug in 0, 0 to the 4th power. So we get 1/4 of 16, which is 4, and 1/4 of 0, which is 0. Oops. And so the answer is 4. Now that's one way to do it. And this is the faster way to do it. It's called changing the limits. Okay? But another way we could do it is ignore the limits. We're just going to do the antiderivative. And again, we get, u cubed just like we would before. So, u is x squared plus 1, du is 2x. And so when we divide by the 2x, that's the part of the chain rule that'll cancel out. We'll get the integral of 2/3. But I'm not going to put any limits at all here. Instead, I'm just going to do this antiderivative. This is 1/4 of u to the 4th power plus c. And I'm going to change it back into x's now. U is x squared plus 1. So 1/4 of x squared plus 1 to the 4th power plus c. And now I'm going to do it from where x goes from 0 to 1. X goes from 0 to 1. So I found the antiderivative, substituted back in the x's, and then said what x goes from. And when I do it, when I plug in 1, I'll get 1/4 of 1 plus 1 is 2, 2 to the 4th. And when I plug in 0, I'll get 1/4 of 0 plus 1 is, uh-oh, did I mess something up here? Oh my gosh, guys. Oh, I got the other one wrong. Hold on. We'll go back to that. It's so embarrassing. So this is 4 minus 1/4. Guys, I said over here that the limits should go from 0 to 2, but that's wrong. When x is 0, u is 1. And so this should go from 1 to 2. So this isn't 1/4 times 0 squared, it's 1/4 times 1 squared. And this is 1/4. I'm so embarrassed. So 4 minus 1/4 is 15/4. Whew, so bad. Over here, when I used the original limits, I didn't make them, this was supposed to go from 1 to 2. So when x was 0, u was 1. When x is 1, u is 2. So the limit should have gone from 1 to 2. When x is 0, u is 1. When x is 1, u is 2. But I can also just go back to the original x's and do it this way. So 15/4. What I'm doing here is I'm saying 4 is 4 over 1, which is 16/4. 16 divided by 4 is 4. And so 16/4 minus 1/4 is 15/4. I'm getting a common denominator. That's where that's coming from. All right, guys, why don't you try one on your own? Some of these are a little bit ugly, so we'll see how you do. Try rewriting this as u's first. So if we do this as u's, clearly u is 1 minus x cubed, because du then will be, oh, be careful here. Some people miss the negative. This is negative 3x squared. And so we're going to divide by negative 3x squared. And the x squareds will cancel out. But there's still a negative 1/3. So negative 1/3 u cubed du. And if I do it in u's, when u is 0, when x is 0, u will be, when x is 0, u will be 1. When x is 2, u will be, when x is 2, 2 cubed is 8, 1 minus 8 is negative 7. And so u should go from 1 to negative 7, which is negative the integral from negative 7 to 1. So I'll just put this negative inside. It'll make it positive 1/3 u cubed du. So we can do it this way. We raise the power by 1. And it's going to go from negative 7 to 1. So this is 1/12 times 1 to the 4th minus 1/12 times negative 7 to the 4th power. Guys, you can use a calculator on this. This is fine to use a calculator on. I don't know what 7 to the 4th is. You're not expected to know it either. So let's see. 1/12 minus 1/12 times 7 to the 4th power. This is negative 200. Now, you could have also done it by not doing the limits at all, converting back to x's. So this could be just like, negative 1/3 times 1 minus x cubed, right? Or whatever when we get back to there. It comes back to this one. We could convert it back to x's and then do the original limits. That would also work and also get us negative 200. All right. Number 7, what is u? Well, clearly u is 2x minus 1 because it's inside the function. So du will be 2. So we're going to have to divide by 2. So we have to divide by this to cancel out the multiplying that we're going to get later. And this is 1 over square root of u. This is power rule. This is 1/2 u to the negative 1/2 power. It's a negative power because it's dividing, and it's the 1/2 power. So this is the integral. And this time I'm going to do it the converting back way. I'm not going to look at the limits just yet. I'm going to raise the power by 1. So negative 1/2 plus 1 is positive 1/2. Negative 1/2 plus 2/2 is positive 1/2. And I need to divide by the new power. A half divided by a half is just 1. Well, that's lucky. So it's u to the 1/2 plus c, and I'm going to go write it back as x's. So u was 2x minus 1. It's the square root of it because it's the 1/2 power, and I'm going to do it from the initial 1 to 5. So when x is 5, this is square root of 9. 2 times 5 is 10, minus 1 is 9. Minus, when x is 1, this is 1. And so we get 3 minus 1, which is 2. Now, you could have right here done the limits and said, hey, look, I'm going to do the limits with u there. When x is 1, u is 1. When x is 5, that's what it goes to, u will be 9. And so this limits would go from 1 to 9, and it would get you the same answer. Okay, a little bit more practice, guys. What is the u here? Well, we know how to do the integral of 1 over x, but this is 1 over something. So we're going to call u 4r plus 2. And so du is du is 4. So we need to divide by a 4th. So we need to divide by 4. And it's the integral of 1 over u du. So sometimes we'll just bring the constant multiplier to the outside. That's fine. And so we get 1/4. This is the integral of 1 over u is natural log of the absolute value of u. And I'm going to do the u's this time. So u goes from 1 to 3. So, x goes from 1 to 3. So u will go from when x is 1, this is 6. When x is 3, this is 4 times 3 is 12. 12 plus 2 is 14. So from 6 to 14. Okay. So this is 1/4 natural log of 14 minus 1/4 natural log of 6. There's actually a cool property you can do here. We can actually simplify this quite a bit. We can factor out the 1/4, and then it's natural log of, remember when you're subtracting, if you have a log of a minus log of b, this is log of a over b. So this can become a single log. This is 14/6. So this is 1/4 natural log of 7/3. We can divide them both by 2. So you can always combine logs that are adding or subtracting. Remember, if logs are adding, you multiply the inside into a single log, and if they're subtracting, you divide. So that's something worth looking at. How about this one? What do you get as your answer? Well, hopefully you see that u here is x plus 2. So the derivative of that is just 1. So dividing by 1 doesn't do anything. This is just it's the same as the integral of e to the u du. And so it's going to be e to the u plus c. And u, I'm going to go back to x's this time. X plus 2 from negative 2 to 2. This is what we're doing. So when I plug in this, I get e to the 4th power minus negative 2 plus 2 is 0, e to the 0, and this can be simplified. So e to the 4th minus 1 is the best way to write this. Now, could I have used the limits for u here instead? Yeah, I could have said it's e to the u from when x is negative 2, u is 0, and when x is 2, u is 4, and I would also get e to the 4th minus e to the 0. These both give the same thing, right? I just want to make sure we know there's 2 products here. All right, how about number 10? Try it on your own. Okay, clearly the inside function here, I hope it's clear. U is x squared plus 1, and part of the reason I know that is because the derivative is 2x, which is basically in the top here. So when I divide x divided by 2x, the x's are going to go away, and so it's 1/2 the integral of 1 over u du. Right? So the integral of 1 over u du is natural log absolute value of u. And let's do it the u's way. So if x goes from 1 to 3, u is going to go, when x is 1, u is 2. When x is 3, u is 10. So we get 1/2 natural log of 10 minus 1/2 natural log of 2. And this is similar to what we just talked about up above. We can factor out the 1/2 and do natural log of 10 minus natural log of 2. When you subtract 2 logs, you can combine it into a single log that is dividing. So it's natural log of 10 over 2, so 1/2 natural log of 5. You'll notice I got rid of the absolute values because 10 and 2 are positive numbers, so the absolute value of a positive number is just a positive number. So 1/2 natural log of 5. You know, if you really wanted to be fancy, we could have done another property of exponents and said that if you have a multiplier, that can become an exponent. So natural log of 5 to the 1/2 power, which is the same as natural log of the square root of 5. This also could have been a way they wrote their answer at the end. So, you know, you are supposed to know your properties of logs from Algebra 2. So, you know, might be worth looking at again. If f of x equals natural log of x over x, what is f prime? Hopefully, we're going to do 2 problems here. One is, what is f prime? And notice this is not u-substitution because you're just doing a derivative. This is quotient rule. It's the derivative of the top times the bottom left alone, minus, we leave the top alone, times the derivative of the bottom over the bottom squared. And so we get 1 minus x natural log of x. Oh, you couldn't see that. Oh no, that was off the screen the whole time. So bad. This is quotient rule. The derivative, if we're doing the derivative, this is a quotient. The derivative of the top times the bottom left alone, minus we leave the bottom alone, or leave the top alone times the derivative of the bottom, all divided by the bottom squared. And so it simplifies to this. So that is the quotient rule. But this is also a cool one to look at as an integral. What about the integral of f of x? What is the integral of the natural log of x over x? So think about what u and du could be. So in this case, u is natural log of x because du, the derivative of natural log of x, is 1 over x. And another way of writing this is instead of dividing by x, this is the same as multiplying by 1 over x. And so this is really multiplying by du. So this is the integral of u du. It's a funny way of looking at it. This is 1/2 u squared plus c. So 1/2 natural log of x squared plus c. So, all right, 2 more problems. What is the average value of this function on the interval from 0 to 2? So you gotta know what average value means. The average value is gonna be the integral from 0 to 2 of x squared square root of x cubed plus 1 divided by 2 minus 0. And now to do this integral, we're gonna need to use u-substitution because this is a function within a function. So u is going to be x cubed plus 1 because it's inside the square root, and its derivative is 3x squared, which is going to cancel out nicely with this. So I'm gonna factor this 2 minus 0 out to the outside. Dividing by 2 minus 0 is the same as multiplying by 1/2. And x squared divided by 3x squared is 1/3. Square root of u du. Let's do this. This is u to the 1/2 power. We need to do the integral. So we're going to get, so we have 1/2 times a third, that's 1/6, times u to the 3/2 power, and we have to do times the reciprocal, divide by 3/2, so 2/3. Ugh, this is getting ugly. So this is 1/9 square root of u cubed from, if x goes from 0 to 2, u is going to go from 1 to, so when x is 0, u is 1. And when x is 2, 2 cubed plus 1 is 9. So we get 1/9 the square root of 9 cubed minus 1/9 the square root of 1 cubed. Square root of 9 is 3. 3 times 3 times 3 is 27. 27 divided by 9 is 3. 1 cubed is 1. So 3 minus 1/9, we need to get this into ninths. 3 is 27 ninths. So 3 over 1 times 9 over 9 gets you there. 27 divided by 9 is 3. Minus 1/9 is 26 ninths. Yuck, that's an ugly problem. I can guarantee you that on the AP exam this year, the year that this one showed up, like this is one that you expect something like 75% of kids across the country to miss. They're just like gonna make a mistake somewhere. So if you missed it, don't feel bad. People make mistakes on questions all the time on the AP exam. They don't expect you to get them all right. But I mean, you can get it. It's just like, boy, was this a lot of work. Okay, dy dx is this. If y equals 0 when x equals pi over 2, what is the value of y when x equals 0? Okay, so 2 ways to do it. One is thinking of this as a rate and using the fundamental theorem of calculus and doing, so it gives you a starting point. So 0 plus the integral from pi over 2 to 0 of sine of x cosine squared of x. The other way to do it is to find the antiderivative and use the initial condition to find what c is. So you would like just find what y equals with a plus c, plug this in for x and y to find what c is, and then plug in x equals 0 to find it. I think I'm going to do it this way. Either way, you're going to have to do the antiderivative of this, which is the key point. Here, clearly the u has to be cosine of x because cosine of x is being squared and the derivative of it is right there. Du is, the derivative of cosine is negative sine of x. And so we're going to divide by negative sine of x and just get a negative 1 in front. So this is negative the integral of of u squared. So it's 1/3 u cubed, negative 1/3 u cubed from, let's see, when x is pi over 2, what is my u? U is cosine. So when x is pi over 2, cosine of pi over 2 is 1. And when x is 0, cosine of 0, oh wait, oh that's wrong, hold on. Cosine of pi over 2 is 0, and cosine of 0, so when x is 0, cosine of 0 is 1. Okay, so that's what it goes from. So this is going to be negative 1/3 is the answer. You're just going to plug in 1, and then this one, what you plug in, will be 0. All right, guys, these are some tough things. Do practice. The key thing is just practice, practice, practice until you're feeling good about it. Whenever you have any questions, ask me questions until you understand it. This is tricky at first until you realize like what you're doing, and then it just becomes kind of automatic. I hope you have a good rest of your day, and I will talk to you next class.